Hello everyone, welcome back to CodeVerse. So today we are going to see our third problem, that is longest consecutive sequence. So I had given an example here that if that array of uh, a particular array and their elements are there. So the first of all let's understand what the problem says. So longest consecutive sequence, it means that for example in this array after like 1 it should come 3, 2, then 3, then 4. Inside array all the elements are there, so here its length is equals to 4. If I'll take 100, then after that it should be 101, again it should be 102. Here the length is equals to 3. So here the longest sequence is consecutive sequence is uh, this 1 2 3 4, and the length is of 4. So first of all, we'll see the brute force approach and how we're going to approach this problem. So think of it. How will you going to do this, right? So what we'll do here, um, see, first the brute force approach. Yeah, sorry, again, sorry for my handwriting. I'll try to improve this, but okay. So what we'll do this, what we'll do, for example, if we'll start with the element 1 or 2. So what we'll do again, we'll do a linear search to check if 103 is present or not. Again we'll do a linear search if 104 is present or not. Right? Are you getting? So similarly we'll follow the elements one by one and we'll check if the element next to it is present or not in the array. So for this, uh, what we'll do, we'll take one variable, that is count for here we are taking count equal to 1, because if the element is 1, so it the longest length in that case will be 1, right? And we'll take the longest will be also 1, and we'll take the starting element, that is x. Here in our array the x is equals the first element is 1 not 2. So just listen by words, right? We'll choose the starting element and we'll search for the next, that is, as I told, we'll search for 103, which is x plus 1. If 103 is not there, for example in the array 103 is not there, so then what we'll do, then we'll move the pointer to next element and again the search. For example, in our example, the next element is 4. See, as we can see, in our example the next element is 4. So here we'll search for 5, that is again x plus 1. If 5 is not there, again it will move. So in that case, suppose the our x will move to 1 not means 100, right? Here 100 is there, see, right? 100 is there. So it will do a linear search from the starting element, right? So for the linear search it will check if 1 is there or not. So here the 101 is present, so in that case we'll increment the counter to from 1 to 2. Again it will search for the 102. If it is there, again the count will be from 2 to 3. So in this way we'll search all the elements, and at the end we'll increment our longest also. Whatever the longest element will go, whatever the longest element will come. So here the longest is 3. Similarly, we'll follow the for this this algorithm for the other elements also. So let me write a pseudocode for this, right? What is called that? The pseudocode, right? Wait. So as I told, first of all we'll take longest equal to 1, as because if no elements were there, so in that case the longest will be 1, right? So first of all will iterate if I equal to 0, I less than an I plus plus, right? And we're initializing array x to array of I. from the starting index we are doing, right? In that case, count will be 1. Here simple. Now again we'll run here the while loop. While we'll do a linear search, right? Linear search. While doing a linear search, if inside array, if x plus 1 is present or not, if this is true, right? If this is true, in that case, x equal to x plus 1, and we'll also increment our count to count plus 1, right? And we'll close out the parenthesis. So for we'll use STL for doing the linear search, or you can also write the proper code for the linear search also. So let us see what is the time complexity here. So we are using the for loop here, right? For that, it will be order of n, right? But we'll check all the elements one by one, one by one. We'll doing linear search again and again. So the time complexity here will be order of n square. So, but this is not an optimal approach. So uh, we'll move to a we'll move for a better solution. Now let us move to the better solution. For the better solution, I am taking quite a long array. For this, the elements are more. So the first step will sort the element. After we'll sort the element. After sorting, this array will be something like this. So what we'll do here, just try to understand. Just think of it. Here's the main point, right? What we'll do here, we'll take some some variables, like we'll take longest is equals to 1, and we'll take a new variable, that is last smaller. I will explain why we are taking this. We are taking it should be very small. I take int min, and we'll take one more, count current element is equals to 0. So why I have taken the last smaller, just try to listen my words. Suppose if I'll take 1, suppose if I'm taking 1, right? So for the consecutive, if it's before 1, 0 should be there in this, 0 should be there in the array. If I'll take 2, 1 should be there in the array. If I'll take 3, 2 should be there in the array. If I'll take 4, 3 should be there in the array, right? So for this purpose, we are taking the last smaller. I will just I'll explain with the example. Just listen. Suppose we'll start from here, right? Suppose a pointer is here in the beginning, right? What we'll do, suppose a pointer is here. If one has to the part of the sequence, then before this, 0 should be there, right? But 0 is not there in the array. 0 is not there. That is the last smaller should be 0 for the one to be the part of the sequence. So in that case, what we'll do, one will be the new sequence, and so as I was telling that for one has to the part of the array, 0 should be present in the element, sorry, in the array, but 0 is not there. So in that case, what we'll do, we'll just uh, make the int min to 1, and current count should also be 1, right? Because if 1 is a part of a sequence, in that case, we are counting one element, and longest is 1, right? Again, the pointer will move from here to here. Again, 1 is there. For that, it will search for 0. 0 is not there. Again, the pointer will move here. Again, 1. Again, it will search for 0, but 0 is not there. The moment it will come here, right? Again, it will search for 1. 2 will search from 1, but 1 is there. So in that case, what we'll do, we'll make the next int min to 2, and count current to 2, and right now the longest is 2. Again the same thing, it will move, it will search for the 3. Again it will move, it will search for the int min should be like the int min has to be 3, but it is not there, right? Again it will move, right? When it come here, 3 is 3 will search for 2, so 2 is there, right? It will be 3, uh, longest will be 3, and count current will be 3. Again it will move, again when it will come here, right? It will search for 3, 3 is there, yeah. It will be 4, longest will be till now the 4, and the count current will also be 4. Now here is the main point, right? The moment the pointer will move here, right? So at 99, at at 90, at sorry, at 100, it will check for the last smaller should be 99, right? But the last smaller is not 99. Here the last smaller is 4. So in that case, whenever this case will come, right? Whenever this type of case will come, that here the at that the array is starting from the new element, right? So in that case, what we'll do, right? It cannot be the part of the sequence, right? So what we'll do, again we'll start from fresh. That is, in that case, uh, count current will be 1, and here the last smaller will be 100, right? 100, right? So what we'll do here, again from 100 it will 100. So again the pointer will move here, right? It will check for 99, and then is not there, right? Again we'll cut, again we'll move here, 101, it will check for the last smaller should be 100. So what we'll do, we'll make this 101, and we'll increment the current counter to 2. Again it will move here, it will check for 101, 101 is there, one, so for 100, but here is 101, so it will not do, it will do nothing, it will move here, right? So it will be 102, and the count current will be 3. So it will go like this way, right? It will follow this algorithm. Now next move to the that is a pseudo coding part. What pseudo code what we'll do, right? So first of all, what we did, we had sorted the element, right? We take longest, we initialize the longest to 1, count current to 0, and last smaller is int mean. Again, sorry for my handwriting, yeah, right? But just focus on the concept, right? So what we did, we iterate through all the arrays, right? For I equal to 0 to n, in this case, right? If array of I minus 1 should equal to last smaller, at what we're doing, we're checking for the previous element, if it is there or not, right? Last smaller. If it is there, then we'll increment the count to count plus 1, right? It's a plus, right? Okay. And we are assigning the last smaller to array of I. What we're doing the same follow a, we did the same thing here, right? And we'll close the parenthesis. This is the if statement, right? And for the one more condition was there, like the 100 condition, when the pointer moved to 100, so it was checking for 199, but at that point 4 was there. So what we'll do, if array of I is not equal to last smaller, right? If array of I is not equal to last smaller, in that case what would be, we are just starting from fresh, count current equal to uh, 1, and last smaller equal to array of I. Then we are closing this, right? Um, the video is getting long, right? So that's it. We're done. And at the end, we'll find the longest from max of longest and count current will return the longest, right? So this is the pseudo code we'll see, but still we haven't arrived at our optimal part. We'll see the optimal case also. So till now we have seen the brute and the better approach. Now we're going to see the optimal approach. So here is the example of array that we have used in the brute force approach. So in optimal approach, what we're going to use, we'll use a set data structure. So in set data structure, what we'll do, uh, we'll put everything in the set as and we know that that the set only stores the unique elements. So the repetition is not allowed in the set, as we can see here. The one is twice, but here we are storing once only. So what we'll do here, uh, we'll iterate through the set one by one. For example, if like the first of all the pointer is here, right? So right now we have 102. So in this case, we will check if any element previous to this element is there or not. So previous to this element will be 101. So here the 101 is there. It means that this like 102 is not the starting point. So again we'll move here, right? So we'll write 4. 3 is there or not? Yes, 3 is there. So 4 is also not the starting element. Again we'll move here. We have 100, right? And the previous element is 99. But in this case, 99 is not there. So it means that 100 is the starting element. So again so once we find the starting element, we will check that next element is there or not. So 101 is there or not? Yes, it's there. 102 is there or not? Yes, it's there. 103 is there or not? No, it's not there. So in this case, the longest will be presently 3. Now after that it will move here, right? 1. So before 1 we have 0, but 0 is not there. It means that 1 is the 1 is the starting element. We'll check 2 is there or not. Yes, 2 is there. We'll check 3 is there or not. Yes, 3 is there. 4 is there or not. Yes, 4 is there. So it means here 5 is there or not. No, 5 is not there. So here the length will be 4. So we'll update the longest to 4. Again similarly we'll check the other elements, like we'll go to 101. In that case it will check for 100, but 100 is there. So we'll go to 3. In that case it will check 2 is there, not 2 is already there. Again we'll move to 2. In this case also it will check 1 is there or not. So 1 is there. So this is the case how we're going to find uh, the optimal approach. Now directly moving to the coding part. So here's the coding part. I'll provide the problem link in the description. So, so what we need here, right? So first of all, what we'll do, we'll take int that equal to a of, we'll define the size of the array, right? Uh, right. Now again, we'll check, right, if there is no element. In that case, what we'll do, we'll return 0, right? Now we'll take one largest that and we initialize it to 1, right? And at the end we want to return largest, right? Largest or longest, we can say anything that we want, right? So no, like we want largest, longest now. So we'll take longest here, right? So what we did, we had taken an un unordered, right? Unordered set data structure we had taken it. That is of int type, and we'll name it as a st. And now we had used a for loop for iterating it, right? 0, right? Then I less than n, I plus plus, right? Now what we did, so first of all, after declaring the set data structure, we are now inserting all the elements of the array into the set data structure. So how will we going to write st dot insert, will insert all the array, right? So array of I. So now we'll iterate through this particular set data structure. So how will iterate in the C++ auto int, or then we'll use clone, then we'll use the name of the set data structure, right? So what we'll do, first of all, use if. First of all, we have check that if any previous element is there or not, right? So if st dot st dot find, right? If st dot find id, that previous element is equal to till end is there or not, right? If it's there, right, so we'll initialize it. What we'll take one variable to count the number of this, and we'll take we'll initialize that to the first element. So x will have the first element, right? Now, sorry. Now you will use while loop, while yeah, while st dot uh, find. Now if it's it, now we'll check the till here we have initialized the first element, right? Now we'll check for the other element, that is the x plus 1 element is there or not, right? So now x plus 1 now is not equal to while dot end. In that case, we're all right. In that case, what we'll do, we'll increment the x to plus 1 and count to count plus 1, right? And at the end, we're going to find longest equal to max of longest comma max. CNT, now we have CNT, right? At the end, and return the longest. So let us check, right? So we did with the code, right? So here, what the time complexity? Here the time complexity is the order of 3n, and order of 3n, the space complexity, we are using one set data structure for, because that the space complexity will be order of n. So till now we are done with the 3 questions. For more such videos, subscribe to my channel, and thank you all.